Golovanov. Can you hear me? Yes. I'm from Vienna, and it's rather difficult for me usually to answer questions where I'm from, because originally I'm from Moscow, from Russia, but I live in Vienna for 30 years. And I have strong background in system sciences, and we used our knowledge in our company to develop information technology which address very important issues of novel platforms for smart cities. If you go around and you will ask anyone here, or we will see on the booth, you will ask, what is smart city? You will have a lot of answers, very different. People don't understand it in a very different way. It can be energy, it can be pollution, it can be parking, it can be everything. So we had an important question to answer. Can we provide integrated view to the smart city, to the urban area, which actually presents linkages between different systems and presents the vision of the whole system of systems in a very simple way, which is useful for municipalities, for burgomeisters, for energy providers, for waste managers, and so on. So this was the questions which we tried to answer. But while answering these questions, we need to take care that the systems are very complex, and they are very changeable, very dynamic in change. And we need to provide clear, simple vision of the very complex system, and it has a lot of interlinked components inside. So how to address this not easy task? In order to address it, we need to make the solution which is easy to maintain by municipalities, and it's addressed to municipalities, because municipalities manage their own vision of the urban area. It should have open data access, it should be easily linked, it should be copyright of the municipality because it's their model, and they should be able to maintain it. It should be easy, and it should provide services not only to administration, but to citizens, to local businesses, to utility providers, to actually stakeholders of the urban area. So when we try to address what's behind these beautiful pictures of any city which you see, you need to address many issues of complexity, linkages, nexus, and we did it in a very straightforward way. We took urban model by ISO 37120 indicators of quality of life as a sample, took open data sets which are corresponding to average city, 50,000 people, let's say in Europe or the United States. It's 60 Excel files, by the way, and implemented real-time model, which I show you a bit later, which provides vision of the whole city. And this model is easily expandable. It's example, and we offer this service to municipality. Please take server, 5 minutes to rent it. It will have ISO model installed, running real-time online. You take sample open data sets, and you change these open data sets after some learning to your data sets. And then you start connecting Internet of Things, smart sensors, SCADA systems, waste management, water management, whatever you have. We call it digital data stream. So this digital data stream can be connected to our system by IP addresses, by standard protocols, and while it's receiving hundreds of thousands of data streams, it's transformed into very simple vision of the complex system. The complex system structure can be not only by ISO, let's say model, energy, transportation, environment, pollution, education, and so on. It can be different. It can be structure, typical structure of the city, which municipalities has. It can go down to each building, each tube behind the building, each energy supply. So the structure of the model can be huge, representing real unique structure of each city. So it has properties. Each node of this structure is hierarchy. It has properties, standard set of properties. I won't go in detail because it's a really big system. It's a very complex system, but we want simple application of this complex system. So this is example of the indicators which are behind. Indicators can be created within 10 minutes. So in Austrian Institute of Technology, in City Keys, and many projects, people discuss a lot of important issues related to key performance indicators for cities. In our system, you can create each indicator within 10 minutes using editor of indicators with drag and drop, and link it to different data sources, open data sources, and have it running real time. So this is a solution which is highly customizable and allows seeing the complex system further. This is an example of so-called dependencies between different indicators. So one indicator, when it receives data, set one portion of the information, it transforms it, calculates indicator, and this indicator goes to any other indicators, several others, including economy, including management, including costs, a lot of indicators. So these linkages between indicators are presented in a special so-called dependency graph, which provides easy vision what's happening and why it's happening. So cause and drill down analysis is visual and easy. So basically the Smart City Monitor consists of these most major components. On the low level it's data sources, on the upper level it's interfaces to, customized interfaces to administration, to municipality, to citizens, which can have their own personal vision of energy supply and the city according to their focus of interest. And these data streams are originated by standard set of protocols with Internet of Things, like RESTful and MQTT and others. And these are examples of typical IoT devices which are used in the cities, which are increasingly growing in number. And big data streams are transformed in real time. It answers the needs of the stakeholders, various stakeholders. And it supports the vision of the city, answering the question, how are you, the city? Like we are in between us, ask you, each other, how are you? So if you ask me, how are you? I am able to answer you only if all my organs, combination of organs, works fine. If something is wrong, I cannot answer. Because if heart is okay, but brains are not, I cannot answer. So we made platform to make model of myself or the city or the enterprise. It's abstract model of public cyber-physical system. And when this model is done and connected to devices, then you can ask model how he is, and the model answer he is fine. So we actually answer the city, state, excellent, optimal, or deficient. And this is major information from management. Management doesn't need disturbance until there is a problem. So if the combination of all the system in the city is fine, I don't need to go and analyze details. It should be within sustainable targets for each property, for each indicator, for each model, for each system. So this is exactly what we do. Now let me quickly present you the model of Smart City on our portal, which you can play. And you can try if you will be interested. We invite for business collaboration. This is growing. This development has growing attention from our European cities, from several business partners. And let's go now to website. The portal is service portal, so it means that it's possible to download the server or set server in the cloud. It's possible to have immediately installed ISO model and template for developing urban model for the real city, starting from ISO. Then it can be added areas, themes, indicators, data streams, links, smart system. It can be added to this model, up, down to each building. And this is our portal, which provides possibility to subscribe for service. We provide platform for municipalities to run the model in their own city. They have own copyright for this model, which can be very big. We train people to run, to prepare the model, run it. We help to maintain it. And there is this very reasonable amount of money which city has to pay each month. It's really not big amount. It's calculated automatically based on city budget, last year, number of citizens in the city, and average salary in the country. Because here, let's say in Spain, in Austria, it's one amount, in Bangladesh it will be different amount. So we want to promote this in different countries, depending on average salary by World Bank. So this is the vision of the city. So you can see on the left side, we call it table vision. It's structured accordingly to ISO standard. So this structure presents you the areas and status of each area. So red is everything is fine, but something is wrong. So it's not sustainable in certain area. In energy or transportation and environment. And if it's wrong, if you click into the red icon, which presents status of the system, then you can have so-called history of change. It's actually fine, not fine, bad, good. It's transition between different states over the time. And this daily, each box is daily view. So if you go to the situation when we have place here, below you have 1 year. And if you go up, please, yes. On the left side you see excellent status, it's green. It means everything was as we planned, but something was better than we planned. There was actually less fires than we planned, in average. So when we go down, you can see the vision of the whole model accordingly to ISO. It's important that this model is customizable. It's not fixed. We can add any area. So this is excellent, this is normal as we planned. It's sustainable. So now we go to next day, 1st of August. Let's go to the 1st of August. And next day, when we click next day, over the night we received additional information, additional data, and now we can see that we have problems in transportation and health, wastewater and urban planning. So now we want to analyze what's happening, where the problem, what's the cause of the problem. So we click down to transportation, and we see that the model of transportation, these are indicators. These indicators present, by the way, this is ISO formula of this indicator, and it presents value of the indicator 171, while we prevent 171.4. When we plan, it should not be more, not less than 171.2, not more. So this is exactly the vision of the situation related to the cause of unsustainable development. So this model is further used for so-called dependency graph. Please, how we receive information to this dependency graph. It's actually a big model with 160 indicators linked to each other, including economy, environment, waste management, and so on. There are a lot of indicators. So you can see the blue, yellow, yes, transportation. New data regarding transportation, click please. It immediately shows you to which indicators this data goes. So it received, and then it calculates one indicator, second indicator, third, and there is a chain of indicators. It's very good to see how economy influence. New data regarding economy immediately change the situation regarding the whole city. So, and pollution as well and transportation. So this is very interesting analysis tool for having, click once, yes. Yeah. Now you see economy changes the whole vision of the city. It calculates so many indicators and provides so important change in the overall picture of the city, real time. Then it can be very important for management because it improves transparency. So now please, let's go to the maps. All these objects presented in different view. It can be table, it can be icon, it can be analytics, various types of analytics, can be graphs, and it can be maps. On the map of the city you can see all the objects real time, providing information regarding ongoing processes. And each object, including public transportation, and every actually object and category in the city can be presented here because it's customizable. It's possible to add any new category. If there is electromobile services, we can add it. And this is easy. So it has sensors, it has video cameras, it provides possibility to analyze video streams as well. So this is highly It's a very powerful system, providing a lot of opportunities for integrated, holistic vision of the whole city. So we are looking for partners in development of projects. It was released this year. It's continuously upgraded. Now we are adding predictive analytics. It means if in this district, in this building, and nearby tube, and something with energy, there is a wrong combination of things, together it can create in 2 weeks a serious problem in this area. It's called predictive analytics. So we are able to do it. We are planning to integrate it into the next version of the system. Then there is integration with building information modeling system, BIM. So there are a lot of interesting applications. So we are looking forward for partnership in business, in Horizon 2020, in structural funds projects, because we had meetings with the European Investment Bank and they told us clearly that they consider projects a minimum 50 million. But information technology component in such project usually maximum 10%, even for Amsterdam and large European city. So it would be good to make city clusters in particular country and add information technology, which we are gladly providing. So this is another way which we would invite people to collaborate. In case you may have questions and answers, we will be happy to answer you in our booth in Advantage Austria. We are today and tomorrow in this booth, and you're welcome.